Hello my dear students. This video is for class 8 subject physics. We are going to learn chapter number 8 electricity part A household electricity. In our daily life, we use electricity in different ways, like to light our homes, schools, office, to run television, etc. Children, you have already learned the use of cells in watches, calculators, etc. in your early classes. Now, in this chapter, you will be learning about the use of mains as a source of electricity for household purpose. Now children, there are two types of current, that is direct current and alternating current. What is direct current? The current that is provided by cell or battery which remains constant with time. It is known as direct current, and the current which is provided by the mains and electric generators are known as alternating currents. Why? Because they change their magnitude and polarity with time. So this chapter we are going to learn more about alternating currents. In class 7 you have already learned that when a cell is connected to a circuit, current flows through the circuit. The current from a cell flows in a circuit due to the motion of electrons in the metallic wire used in that circuit. A cell has a potential difference between its electrodes, that is anode and cathode. Now what is this potential difference? It can be defined as the work done in moving a unit charge from one electrode to another electrode, and it is expressed in the unit volt after the name of the scientist Alessandro Volta. And children, current can be defined as the rate of flow of charges in a unit time. It is measured in ampere after the name of the scientist Henri Marie Ampere. Children, now look at the circuit given here. Suppose a current I flows through a conductor of resistance R for time t when a source of potential difference V is connected across its end. We are here to find out the amount of electrical energy supplied by the source. Now by definition we know that potential difference is the work done in moving a unit charge. So work needed to move a charge Q through a potential difference V is W is equal to Q into V. Now current I is equal to charge Q upon time t. So we can say Q is equal to I into T. So now the formula will become W is equal to V into I into T. The formula W is equal to V into I into T gives the electrical energy W supplied by the source in providing the current I for time t in the conductor under a potential difference V. Now power is the rate of doing work. So we have the formula P is equal to W upon T. We already have the formula W is equal to V into I into T. So we will substitute that formula. So we have V into I into T divided by T, which is equal to V into I. Thus we can say that power in watt will be equal to potential difference in volt multiplied by current in ampere. That is 1 watt is equal to 1 volt into 1 ampere. Let us now discuss transmission of power from the power generating station to the consumer. Electric power is generated at the power generating stations. At the generating station, the electric power is generated at 11 kilovolt. The voltage of the power generated at the generating station is first raised from 11 kilovolt to 132 kilovolt to reduce loss of energy in transmission due to heating of line wires, and then is transmitted to the grid substation. At the grid substation, its voltage is further reduced from 132 kilovolt to 33 kilovolt before it is sent to the main substation. Here its voltage is further reduced to 11 kilovolt. Once reduced, the power is supplied to the city substation where its voltage is further reduced to 220 volt before it is supplied to the consumer. Let us now learn about supply of power to a house. To supply electric power to a house from the city substation, either the overhead wires or cables on poles or an underground cable is used. The cable have three wires that include live wire, neutral wire and earth wire. The live wire is also called the phase wire, which is at 220 volt and it carries current from the source to the distribution board. The neutral wire is for the return path of the current and the earth wire passes the current to the earth. In the cable, the live, neutral and earth wires have different insulations so that they can be easily distinguished. Live wire is red or brown in color. It is used to carry current from the source to the appliance. Neutral wire is black or light blue in color and it is used to provide the return path from the appliance to the source. And finally, earth wire is in green or yellow color and it provides the connection to earth. Now let us learn how connection is given from pole to the distribution board. To connect the cable from pole to the meter in a house, first a fuse of high rating is connected in the live wire at the pole or just before the meter. And this fuse is called the company fuse or pole fuse. Children, remember, only the electric supply company staff are authorized to handle it. The rating of this fuse depends on the load for which connection is taken from the company. After the company fuse, the cable is connected to an electric meter. This electric meter is usually mounted on the front or outside wall of the house. From the meter, connections are made to the distribution board through a main fuse and a main switch. The main fuse is connected to the live wire, while the main switch is connected to the live and neutral wires. Electrical energy is generally measured in a unit called Board of Trade Unit or kilowatt hour. 1 kilowatt hour is defined as the amount of energy consumed when an electrical appliance of power 1 kilowatt is used for 1 hour. The energy consumed in our houses, shops, factories, etc. is measured in kilowatt hour. Or we can say that the commercial unit of electrical energy is kilowatt hour. Now, power is equal to energy upon time. So energy can be calculated as power into time. So energy in kilowatt hour will be equal to power in kilowatt into time in hour. So 1 kilowatt hour is equal to 1 kilowatt into 1 hour. Children, 1 kilowatt is equal to 1000 watt and 1 hour is equal to 3600 seconds. So 1000 into 3600 will be equal to 36 lakh joule, or we can say 3.6 into 10 to the power 6 joule. Children, here we have converted kilowatt hour in terms of joule. So 1 kilowatt hour will be equal to 3.6 into 10 to the power 6 joule. Next, we will learn about electric meter. Electric meter, which is also known as kilowatt hour meter, is used to measure the amount of electric energy consumed by the consumer in the unit kilowatt hour, and for this we pay the electricity bill to the electricity board. The given figure shows the kilowatt hour meter, and the main part of this meter is the armature which is connected to the main line. When any electrical appliances is put on, the electric current flows which rotates the armature, and the counter fixed on the armature reads the number of rotations. Children, look at the diagram given on the right side. It shows the 5 dials on the counter which is used to read the electricity consumption. The 5 dials from right to left measure the energy in units, tens, hundreds, thousands and 10,000 respectively. And in the figure you can see the reading on the meter is 49180. So it is 49,180 kilowatt hour. Nowadays, these old electric meters are replaced by the electronic digital meters, and you can see it is different from the old meters. You can see the electronic digital meters where directly you can see the readings. Let us now see activity to find the consumption of electricity in a month and to pay the electricity bill based on the reading. So here children you have diagram A which shows the initial readings in the meter and diagram B which shows the final reading in the meter. So A shows the reading, that is initial reading, that is 49180, that is 49,180 kilowatt hour, and the reading on the second diagram is 50625, that is 50,625 kilowatt hour. So the total consumption in the month can be calculated by subtracting both the readings, which comes out to be 1445 kilowatt hour. That is, the electricity consumed is 1445 units. And if the rate of electricity per unit is 6.25, then the bill will be 1445 units multiplied by 6.25, which comes to 9,031.25 rupees. Let us now learn about electric fuse, a safety device. An electric fuse is used to limit the current in an electric circuit. It means it is used to safeguard the circuit and the appliances connected in the circuit from being damaged if the current in the circuit exceeds the specified value due to voltage fluctuation or short circuiting. Now this figure shows the diagram or the fuse arrangement which is used commonly in our household circuits. It consists of a fuse wire F which is stretched between the two terminals T1 and T2, and it is in a porcelain holder. This holder fits into a porcelain socket. Let us now see the purpose of fuse wire. For that, first of all, we will have to know what is short circuit. If the insulation on the wire of cable used in wiring breaks, then the live wire comes in contact with the neutral wire and this is known as short circuit. During this time, maximum current will pass through the wire, which can cause burning of the wire due to excessive heat. Similarly, if there is a voltage fluctuation, sometimes high current flows through the wire, which can also cause burning of the wires. To prevent this damage, fuse is connected to the live wire of the circuit. And when there is a short circuit, the fuse wire gets heated up to the extent that it melts. As a result, a gap is produced in the live wire and the circuit becomes incomplete or breaks. And so no current will then flow and the appliance or the circuit is saved. After removing the fault in the circuit, a new fuse wire is fixed between the terminal T1 and T2 to complete the circuit again. Children, we have already seen what is electric fuse and what is the purpose of fuse. So now coming to the topic characteristics of fuse. First one, fuse wire is a short wire with a low melting point and it is made up of an alloy of lead and tin. It melts at about 200 degrees Celsius. Second point, fuse wire is always connected in series with the live wire. Its temperature rises much faster than the connecting wire when an excessive current flows because of its resistance. Point number 3. The thickness of fuse wire depends on the current rating of it. Higher the rating, thicker is the wire. For example, a 15 ampere fuse is thicker than the 5 ampere fuse. The heating of fuse wire does not depend on its length. You have to take a note that an ordinary wire should not be used as a fuse wire because its melting point is much high. A fuse wire should be such that it should have a low melting point, so we cannot take an ordinary copper wire as a fuse wire. Now we will learn about an alternative to a fuse wire. Nowadays, miniature circuit breaker, that is MCB, is used instead of fuse wire, as they switch off the circuit in a very short time in case of a short circuiting. So let us see what is MCB. MCB, or miniature circuit breaker, is an automatic switch which is used nowadays to protect the household wiring from the excessive flow of electric current in a circuit. When the current flow is in excess, the MCB automatically falls down to break the electric circuit. Children, you can see that in the diagram there is a switch which automatically falls when the electric current increases in a circuit. It can later be reset after the fault is rectified. Next topic is earthing of the appliances. The metallic outer body of every appliance such as refrigerator, ovens and geysers are connected to the earth wire. The reason is that sometimes due to breaking of insulation of wires, live wire come in contact with the body of the appliances and we may get a fatal shock if the appliance is touched. And suppose if the appliance is earthed, then the current will pass to the earth and we will be protected from the electric shock. As a result, a metallic outer body of appliances are always connected to the earth wire. Apart from the uses of electricity, there are a number of hazards of electricity too. Number one, we can say, if the number of electrical gadgets connected in a circuit at a time is more, a heavy current flows through the connecting wires. Or in other words, we can say the house circuit gets overloaded. During this time, there is a chance of overheating of the electric wires, which may cause short circuiting and even electric fire. Second point says, sometimes due to poor insulation of wire, the live wire may touch the neutral wire, which may lead to short circuiting and the flow of current become excess. During this time, it can damage electrical appliances such as TV, refrigerators, bulbs, etc. And even the wires can catch fire, leading to electric fire. So point number 1 and 2 both points to the mishap caused by electric fire. And the last point is, if a person comes in contact with a live wire, he may get an electric shock, and if it is a huge shock, it can cause death. Children, now let us see some precautions to be taken while using electricity. First, we should not touch switches with wet hands. The connecting wires to the plug, sockets and switches should be tightly joined. We should ensure that all the appliances are properly earthed. We should not try to repair any appliance while it is in use. We should ensure that the MCB or fuse and switch are connected to the live wire. The wiring used must have proper insulation. The ordinary copper wire should not be used as a fuse wire because the melting point of copper is 1080 degrees Celsius. So it will not melt even if the current exceeds its safe limit. To switch off the gadgets like TV, press, air conditioner, etc., take out the plug from the socket instead of using the remote. Children, I hope all the topics discussed in this video of Part A, Household Electricity, is very much clear to you. Any doubts will be cleared in the online classes. Thank you and have a nice day.